Latin square designs. What is this? How do I use it? Well, we all have seen Latin square designs in Sudoku puzzles. Now, in Sudoku puzzles, we know that numbers can't repeat in the same rows, the same column, or in the same little square. This is extremely similar to Latin square design as it is a Latin square design. We will be using these processes and looking at how to use them, how to set up the table, and how to use it on a manufacturing floor. So what is a Latin square design? Well, to set up a Latin square matrix, you need three variables. These variables need to not interact with each other, and they need to be in specific combinations. One variable will be assigned the column, one the row, and one the treatments, or what happens inside of the little matrices. In this example, the two cars and the bicycle. Now, the cars and bike cannot repeat in the same column, nor can they repeat in the same row, similar to Sudoku. Now let's look at how we can use this in an engineering perspective and setup. So here we have an imaginary manufacturing floor. We have 5 machines, 5 operators, and 5 possible protocols for this new component we're about to produce. We want to produce the most amount of components per hour. So which of these protocols will be the best choice? We have the machines, we have the operators, and they will influence this. So in order to look at which protocol is the best, we need to set up a matrix that test each operator and machine combination so we can eliminate the nuisance error that they will introduce into the system. From that example, we get the following matrix. Each operator in each machine was assigned a different treatment, A, B, C, D, or E. Each of these will produce a certain number of components which can be recorded in the associated square. This table can then go through the ANOVA process in order for us to gain the statistical data that we desire. Why do we go through this trouble if an ANOVA process is still required? Well, an ANOVA process can only look at 2 variables. This allows us to look at 3. We create the matrix that can go through it without a full 3-way ANOVA cycle, which is the biggest benefit from using a Latin square design. Now, the con is you do have to have the same number of variables in the row and in the column as the number of treatments, and none of the treatments can duplicate in the same row or in the same column. Otherwise, the error produced would invalidate the Latin square matrix, and this process cannot be used. Typically, you need at least 4 to 9 variables in any combination, either 4 columns to 4 matrices and 4 treatments, or 9, 9, and 9. Otherwise, we start to get too small or too big matrices for this system to handle. I hope this short video has shown you how to use a Latin square design and where it might be used. The following pros and cons do need to be considered when utilizing this, but I hope you go forward and use Latin square design in your futures as engineers with confidence.